Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about solution to our plastic pollution. So let's dive right into it. Now, before we understand this pollution aspect, we have to understand what exactly is the problem. The problem is we are a very living embodiment of the saying, be careful what you wish for, you might get it. So we asked for a magic material that's something that can withstand nature. Meaning, if you think about metal, we feel it's a strong, sturdy thing, it can handle some stuff. Nature is like, nah, bruh, we can oxidize it. So not that strong. You're like wood, strong, solid, waterproof and all that jazz. Nature is like, nah, bruh, we have termites that's gonna eat it. So that's the whole point. We wanted a material that is indefinitely resistant to nature, and we got it. That was the problem. Now, biggest issue is one thing you have to understand. Many times people wrongly so think that plastic is wrong. No, plastic is perfect material. We asked for a magical material, we got it. We need it. Only difference is we forgot to close the loop. Meaning, you're supposed to make plastic, use the plastic, consume the plastic, or do something with it. Meaning, like, I got this, like, this is sorted. Then you create new one, then you cycle it. Now, what we did is like, make plastic, use the plastic, throw away the plastic. Make the plastic, use the plastic, throw away the plastic. That created a garbage. Think of it this way. Like, so you bought the most amazing air conditioner that is like super powerful, super efficient and all that jazz. You have connected like 3-phase power and all that jazz, but you let a door open in your house. What the hell is gonna do? That's the same thing happened here. We did not close the loop, and you have to understand it. Nature cannot do anything about it. This is like perfect. Again, we wanted a material that can do that. Nature is just like, nah, bro, I can't do anything to it. All it can do is just break it down into microplastic, and that has a weird side effect. It kind of makes it look like anytime plastic goes into the sea, because it gets chopped into microplastic, we have a illusion that it's sorted, like nature kind of digested it. Not really. And it's now coming back with a vengeance. We are getting it in our food, especially people who are eating a lot of seafoods, fish and all that jazz. Even salts have it, and at this point in time, people are finding it out in our body parts and blood. So you have to understand that, like, this is brutal. It's coming back with a vengeance. Now, the first common reaction, knee-jerk reaction many times people have is like, let's ban plastic. Here's the deal, we cannot stop using it fundamentally unless you want to reduce our lifespan. We have to have it simply because there is no alternate. Simply go to a medical store, any medical field, see how many things are made out of plastic, and see how many things you can replace with something that is cost effective and efficient. Nothing even comes close. Nothing. Like, the reason we can medicate such a large portion of population and make them healthy, safe and all that jazz, simply because we have plastic to package up the pills. Same goes for things, and again, in the pandemic, imagine if you did not have plastic. Again, these things will not exist. Tada. So that's the reality of it. And I'm just talking the medical field, because again, people have this like, no, I can survive without it. Nah, bro, you cannot survive without this. And I'm not even going to go into food industry, without which you seriously will not survive. So realistically, we cannot live without them. We just have to close the loop. That's the problem that we did. It's like, we made it, we used it, we threw it away. We should not have that. We made it, we used it, and we digested it. So that's the problem. That's the issue. That's why we have microplastic at this point. And there is nothing wrong with plastic. We can use plastic for 10,000 years. Not a single problem will occur if we can close the loop. So what are the options? First option that the knee-jerk reaction creates is alternative. Now, you have to understand it. We cannot replace all types of plastic, meaning even think about what kind of procedures you have to create in order to create a replacement for syringe that is cost effective and has same efficiency as a normal syringe. Good luck with that. It will not work. However, that being said, that is absolutely true that we cannot replace every single type of plastic that is in use. There are many that can be done. There are select alternatives that is possible. So we should switch to that. For example, styrofoam is a big hassle at this point in time, and it's a one-use system because inherently is designed to have your box, have your stuff, package it. The moment a customer gets your stuff, then it throws it away. Here's the deal. What if we had something that does work exactly the same, but the moment we throw it away, it disintegrates? Welcome mycelium. Now, mycelium system is like starting to becoming cost effective. A lot of people are pouring their money into it, and it's a really good alternative to something that we can replace. This is generally used for basically use once packaging material. Wouldn't it be great to have a use once packaging material that is just like biodegradable? It is biodegradable. It's just a fungal mycelium network. So fundamentally it disintegrates the moment you break it out. And again, they are biologically safe because you have to cook them to sterilize them. So they are safe. And the moment you use it, let's say you received your wine bottle, you take out the wine bottle, you take it, you break it, throw it away, lol. And even if you just throw it as a whole piece, nature will just disintegrate this puppy without any issue. So that's one way of taking care of the situation. Like, just one tool. Another tool is cutlery. We are using a lot of stuff for our plates and all that jazz, using stuff Again, there are alternatives that we can utilize. There are alternatives that are using sugarcane, there are alternatives that are using leaves. There are a lot of options, but here's the all of them have the property of being degradable, biodegradable, meaning nature will digest it without any issue. So we can switch those things. Now, what does have it, what is the benefit of doing it on a large scale? Large scale benefit would be it will reduce new production. Now again, it will not reduce it to like zero level. Do not expect that. However, any reduction, like let's say instead of making 1,000 metric ton, we are making let's say 800 metric ton. That's good. I will take that. That's a really good source. And again, the benefit is because we have learned from the experience of plastic, all the new replacement we are creating will not become a mess in the future. So that's one tool in your toolkit of handling plastic. At least reduce the things that we can reduce. Not everything, but things that we can reduce, we should have some alternative. And thankfully, because of the modern pressure, a lot of new alternatives have started to hit the market. Then we come to the most, what about the plastics that we have to use? Well, the simplest solution is plastic to fuel, meaning you convert it into fuel. Now you're like, how the heck you can make plastic into fuel? We don't think about like, put your plastic in your diesel generator and voila, electricity. But in principle, you can do that simply because if you zoom down into it, like you go into the molecular level, what exactly you will find in a plastic? Hydrocarbon chains. At the end of the day, that's what it is. Again, there are some trace elements, other elements, be it oxygen, be it nitrogen, be it sulfur, whatever have you. Of course, that's the whole point of, that's why we have so many, plastic variations. Again, you change things, you change the property. But at the end of the day, core level, it's still a hydrocarbon, majority hydrocarbon. What does that mean? That simply means if you burn it, it's exothermically burning, meaning it will give you energy. And it's not that shocking if you know that most plastic is made out of crude oil. It's inherently a crude oil product. So, and that's why we cannot even recycle it, because crude oil is cheap, and making it as a byproduct of that system that is super profitable, having a byproduct system, inherently plastic prices are so cheap that you cannot collect and recycle it. It will simply not be cost effective. Engineers will say go, scientists will say go. The moment economists get that department, it's like, yeah bro, no, not happening. Now like, what about the plastic that we are recycling? A, we are not recycling enough of it. B, all the recycling is done by either for PR moves or basically there is government law. Like, it's not economical. Like, why do we recycle glass bottles? It's economical. Why do we recycle Coke cans? It's economical. Why don't we recycle plastic? That's the same problem. It's just not economical. You can brute force it, but it will not work. So fundamentally, we cannot do anything about it. However, if we convert it into fuel, fuel has high enough value per kilogram, per liter, that people are like, you know what, it's financially viable to do. So what do you do? To basically, it's a crude oil product, but it does not burn directly. Again, we work our ass off to have plastics that are like, not, catch on flames instantly, but we have to do is pyrolysis. Thankfully, it's a super easy trick. All it is cooking without oxygen. You put your stuff in a vessel and you just seal that puppy up and then you just cook it. You cook it up around 600 degrees Celsius. Again, it's a so basic project that almost all school, colleges, university can teach you about this. Like, again, it's a common thing, even in India, common thing. And I'm providing a video down below, you can check it out, and it's super common thing. And they are like consuming around 400 tons of plastic, and I'm saying 400 kilograms of basically plastic, and getting almost 300 kilograms of fuel out of it, almost 350 liters, something like that. So you get that point. Like, it's fuel, it's solid, you are breaking it down long chains into smaller chains. What happens when you do that? You go up from solid, liquid to gas. Again, we don't want gas, we want liquid fuel, and the output of this thing is molecularly same to diesel or petrol, even jet fuel. Depending on the temperature and ingredients that you put into it, you can get exactly that one. And here's the company that in India doing it, and across the world, they're selling the fuel to industry for much lower price. Now here's the deal. The fuel is something that is always consumed. We always want liquid fuel. You have a liquid fuel source that, like, everybody will buy it. That creates an incentive. Whereas, like, what, the plastic that we cannot do anything about, for example, medical grade plastics, we have to have that. What if you just convert it into fuel? Now, what's the benefit of that? It removes microplastic from equation, meaning you will no longer have soil contamination, salt water, and our blood contamination will not happen. That's one easy way. And economics support it. That's the most amazing aspect of it. It's simple, basic technology, and economics supports it. It can be scaled up to very large scale. At this point in time, there are many plants that are already starting to do it. We just want much larger adoption rate. That will start to slowly bring down our oil to basically crude oil to plastic to microplastic to crude oil to plastic to oil again. So we will close the loop. That's one way of doing it. What about carbon dioxide? Again, at this point in time, who is the bigger enemy? Microplastic, not carbon dioxide. And not to mention, in future, we're gonna switch from crude oil to algae crude oils. In those sort of scenarios, it will be a completely closed loop system. So we don't have to worry about it. So plastic to fuel is a very powerful tool of taking care of nasty plastics. We just like take care of it. Don't think too much about it. It's like, and it's profitable. What about other options? Well, we have too much garbage. So what if we take plastic waste to product approach? Now, plastics last forever. That's the biggest problem with it. But again, that's a desirable thing. Imagine it this way. Somebody sold you let's say a pavement that is like, you put it here and you do not think about it. Like how long? No, you just don't think about it. It's like you put it there, maybe 10,000 years later, you will still find it there. So it's like, you like, shut up and take my money. There are many things we want that strong. So somebody came up with this idea, like this amazingly, capable lady, and I provided the video down below, and she's from Kenya, and you can check that. It's like mind-boggling. Nobody thought of it. Like, take the plastic, compress that puppy, heat that puppy to around 300 degrees Celsius, mix sand with it, and you make bricks that are like literally 30 to 40% cheaper than cement bricks, again the pavement bricks, and longer lasting. It's like, thank you. And there are some people who are working to make sure that they can make plastics and combine that with roads. So road can last longer, because again, plastic is resilient to one thing that almost all our structural material cannot handle: water. Water will destroy your cement. Water will destroy your rebars. Plastic is like, nah, bro, nah. We don't give a damn. That's the whole point. So plastic lasts forever. What if you use it where we want it to last forever? So that's one option. However, be very mindful. This does not solve microplastic problem. It reduces it, meaning, let's say this is a pavement. A lot of people are gonna walk it. Again, small particles will chip up, but again, if the whole thing was left into a landmine, that was a much bigger hassle. So instead of releasing, let's say, you had 100 tons, 100 turn into microplastic, you will still have that 100 tons turn into microplastic, but instead of happening over, let's say, 10 years, it will happen over century. So that's like, it's a slow down system. And there are other things that are, like, for example, making bricks, making to road base layer, so it's not getting eroded and it's just there, because there is only one weakness plastic has, that's ultraviolet. If you can bury it deep enough and you just use the basically plastic as the foundation and then other things as a road layer, then it's not perfect. It's like it's protected from one thing that can break it, and everything that is inside road is weak to water. Plastic will be like, no bro, I got this. So you can utilize the properties here, and we have enough garbage to make this work. And I'm genuinely frustrated. Like, they gave her a grant, $10,000. I'm like, are you freaking serious? Like, she has a company that physically works. Like, she has a physical company that makes profit and feeds 20 employees, and you are like, here's $10,000. Are you kidding me? It's like, just go there and be like, okay, these are your machines. Let me automate the hell out of it. Again, the machines they are using is very sloppy, again, very low cost. But again, imagine if that was mass produced and made into a larger system. Right now, she is clearing around a few tons plastic per day. Imagine few hundred tons per day. And yes, this is much better than having that into a landfill where it becomes going to food plastic and microplastic and all that jazz into underground waters also. So this is much better. This is like almost an entrapment, but compared to everything else, this is a really good option. So waste to products are also a possible approach. There are other people who are working on making sure styrofoam becomes into activated charcoal, which we do have a lot of use for. So there are a lot of people who are working there. That's the third tool we can utilize. First, we use alternatives. Second, we make it into fuel. Third, we use into a final product. Then we come to the final Brahmastra option. That is Biogra upgrade the biology itself, meaning the end game weapon. So nature has already built it. Now you have to understand it. We are not the first species. Plants were kind of, quote unquote, the first species that built a structure that was like strong. Wood. But here's the deal, nature figured out how to digest wood. Now imagine it this way. Nature did not have a way to digest wood. What will happen? Same thing, same problem. Like, we have microplastic, we may have micro wood problems, but again, nature figured it out. And same thing has happened. Nature has already figured out, and we figured it out in 2016. So from 2016, you will notice there is a lot of articles about this. Yeah, that's because in Japan, 2016, somebody figured it out. Like, there are enzymes that are breaking plastics, like PET plastic, basically single-use plastic, into a smaller constituent. Then it gets down to even smaller constituent. At that point in time, it's a glycol output and some sort of acid, meaning basically things that nature knows how to handle without any issue. And not to mention, they can even recycle this properly. Normal plastic cannot be recycled because it degrades in quality. Like, same reason you cannot recycle plastic, paper, you cannot recycle carbon fiber. Again, structural materials are not something that you can recycle. You can recycle anything that you can melt. That's super easy. Like aluminum, do melt it, rebuild it, no problem. But anything that has structure, like especially carbon fiber and polymers, they don't work with recycling. Again, you can try it, but this, because it breaks down on a molecular level, it's far more, quality wise is literally the same. There is not even a single, microscopic difference. So normal recycling will degrade the plastic. It can only be done 2 or 3 times, but this can done as many times as you need to. So that was the discovery in 2016. Now they have found a lot of worms that are doing it. They have found a lot of microbiology that is doing it. But at the end of the day, none of them do anything. What they do is utilize the enzymes in their gut, quote unquote. So we have figured out that enzymes now, After that enzyme was found, it does work. That's the good news. Bad news is super slow, meaning it does work, it does do the job that we want it to do, but it will take, even just to digest one bottle, it could take around months or years. So not fast enough. So what we did is take that enzyme, and then some people was like, what if we add AI to it? So they created multiple variations of enzymes. Again, enzymes we good at, because again, majority of your food industry and pharmaceutical industry, they know enzymes like back of their hand. They're like, we got this. You just give them the formula and they're like, dude, 5,000 ton next day. 24-hour Amazon delivery. So enzymes, what we got it. We just have to figure out the right mix for it. So they used AI to create thousands of variations and then run through simulations and figure out which is the final one. And the final one they are creating is something that can really work fast, meaning something that will take months to hours, as in 48 hours kind of thing. So if that rate is done, and the end game is like, you will have this powder packet, enzyme powder, and you just throw it into a landmine, and you will come after a few days and it's like, plastic is gone, digested, carbon dioxide and this, like, acid. Basically nature will take care of it after a while. That's the whole point. That's the end game. And some people were suggesting, which again I do kind of agree, is like, if we had let plastic problem just go, after a while we may randomly find, like, microplastic in the oceans are going down, because some sea creature would have figured out how to use it, or some enzymes would have, again, which already have happened. It's natural selection on turbocharged speed. So because again, either you learn to deal with it or you die because of it. So it's literally natural selection. Again, because of us acting as a bad person, but again, we are not the first species. The first species that did that was the species that turned the carbon dioxide atmosphere into oxygen atmosphere, and oxygen was the poison for them. It's common thing. It's like life does this sort of thing. So plastic is not bad. We just have to close the loop. That's the first thing you have to understand. And we have multiple tools. We can use alternatives. We can make it into fuel. We can make it into products, and we can upgrade the biology. Now, upgrading the biology does have that one side effect that right now it does not work on every type of plastics. Meaning, do not think about just PVC pipe you throw into the ground and it's like dissolves. No. It is very good for PET, and we kind of want it this way because again, we only want to take care of single-use plastic, and everything else we can loop it, because again, if PVC pipes are big enough structure and you have recycling it, you can convert it into fuel, because super easy. It's like collection is the easy part. So, and not to mention, you do not want to our biosystem to have enzymes that can break our like plastic, simply because how the heck you will have a medicine delivery after that. That's one thing. We do not want like a magical solution where it's like, yeah, it can destroy any plastic, and then afterwards like, yeah, we don't have syringes anymore. That's one thing. But this is also final option, and a lot of people are working. That's why like every year from 2016 you're getting like, this worm is eating plastic, this is bacteria is dissolving, this enzyme is doing that. Yeah, we found it. We're just now making it brute force powerful. Basically, we have the V2 rocket, now we are making Saturn V rocket. So that's final option. That's like, the end game option. So this was my presentation on how to handle plastic pollution. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.